Alright guys, this is a class opener and you're going to be doing these questions. It's all on factoring, and you always want to try to factor out the GCF first. Now what does that mean? Factoring out the GCF, what does that mean? It means when you pull out the greatest common value from all, notice that it's underlined, from all of the terms of a polynomial. So you want to pull out the greatest value that's in common from all of the terms of a polynomial. So if we jump to number one, we have a binomial here, right? It's two terms, one term, two terms. So what is the greatest common value, the greatest common factor, the GCF? Well, if you look at the coefficient 4 and the coefficient 16, you're probably thinking, hey, I could pull out a 2 from both terms, but that's not the greatest value you could pull out. The greatest value would be 4. And if you pull out a 4, what would be left inside? It's kind of like doing reverse distributive property. In other words, 4 times what would get you back to a 4d squared? Well, that would be a 1d squared. Again, 4 times 1 is 4, and the d squared's up there. So 4 times 1d is 4d squared. And then you say 4 times what gets you back to the 16? 4 times 4 gets you back to the 16. And ladies and gentlemen, this is what you call factoring out the GCF. What's the GCF? 4 was the GCF. That's what we pulled out. Let's move on to number 2. Number 2, we have another binomial, but there's several or a couple of variables in here, a's and d's. Let's start with the coefficient, 15 and 30. Could you pull out a 5 from both of them? Yeah, but that's not the greatest value you could pull out. You could actually pull out a 15 from here and a 15 from there, right? If you pull out a 15, actually, before we even say if we pull out a 15, we are pulling out a 15, but what else could you pull out? Well, you have an a right here, and you have an a right here. So what is the maximum amount of a's that you could pull out from both? Well, the maximum amount of a's you could pull out from both is simply 1a. Yeah, it's true that you have 2 a's over here, but over here you only have 1a. So the maximum amount of a's that you could pull out from all terms at the same time is simply 1a. So far our GCF is 15a, but let's also pull out, there's a d here and a d there. There's actually 2 d's right here, but the maximum that we could pull out from both of them at the same time would be one single d. So d goes out on the outside. So the GCF is 15AD. And what would be left on the inside? Well, if I take out the 15AD, 15AD times what gets us 15AD? Well, you would put a 1 right there, because 15AD times 1 is the same thing, 15AD. And then when we think of 15AD times what gets us a positive 30a squared d squared, we can start with the coefficient. 15 times what gets you a positive 30? Well, 15 times positive 2 would get you a positive 30. And then let's go for the a. A times what will get you an a squared? A times a will get you an a squared. D times what will get you a d squared? D times d will get you a d squared. So ladies and gentlemen, the final answer here, the final factored form is 15AD times 1 plus 2AD. The GCF was 15AD, and after pulling it out, you just have a 1 left over with a plus 2AD left over. Let's do another. All right, so 36 and 48. Well, I know that both of them are divisible by 2, so maybe I could pull out a 2, but maybe 4 works, right? 4 works. 4 times 9 is 36, and 4 times 12 is 48. But maybe higher numbers work. So we need to think about this. 12 is actually the greatest common value that you could pull out, greatest common multiple from 36 and 48. So if we pull out the 12, what else could we pull out besides the multiple of 12? Well, we have x here and x there. There's 2 x's here, but we can only pull out a maximum of 1 x from all terms at the same time. And we have 2 y's here and 1 y over here, but we could pull out a maximum of only 1 y. So we're going to pull out 1 x and 1 y. Then we're going to write the parentheses, and we're going to write whatever's left over. I'm going to do it in blue this time. So if I did pull out a 12xy from this first term, you could think of it as actually distributing. 12 times what gets you that 36? 12 times 3 gets you that 36. And then you could think of it as x times what gets you x. You don't have to worry about it because it's already there. And then how about y? Y times what gets you a y squared? That would be y times y gets you a y squared. Now to move on to the next one, 12 times what gets you a negative 48? 12 times negative 4 gets you a negative 48. And then again, the letters x times what gets us x squared? X times x gets us x squared. And then y times what gets us y? You don't have to put anything because, I mean, you could technically put a 1, but that would be pointless. So since there's already a y here, you don't have to worry about putting a y here. Even if you did put a y, that would be wrong because y times y is y squared, and you just want the y. You already have one y. Anyways, that's the final factored form right there. 12xy, parenthesis 3y minus 4x. Done. Number 4, we don't have a binomial here. We actually have a trinomial. 1, 2, 3 terms. There's 3 terms right here. Okay, so what could we pull out? What's the greatest common value, the GCF, the greatest common value that we could pull out from all 3 of them? Well, let's talk about coefficients first. 8, 24, and 16. Well, maybe 8, right? 8 is 8. 8 times 3 is 24, and 8 times 2 is 16. So for sure, we could pull out an 8. Now, what else do we have in common in all 3 terms? We have 2 p's right here. We have 1 p right here, and we have 1 p over here. So that means that we could pull out a maximum of 1 single p from all terms at the same time. 1 p here, 1 p there, 1 p there. Take out 1 p from all 3 terms, from all terms at the same time. So I'm going to have an 8p as my GCF, but we also have r's. We have 2 r's here, we have 3 r's here, we only have 1 r here. So the maximum amount of r's that we could pull out from all terms, the maximum amount of r's that we could pull out from all terms is just 1 r. So the GCF really is 8pr. Now, what would be left on the inside if I pull out an 8pr from each of these terms? If I pulled out an 8pr from here, we could think of it as a coefficient. 8 times what gets us 8? 8 times 1 gets us 8. Okay, so let's put a 1 right there. What about the p? P times what gets you a p squared? P times p gets you a p squared. And then also r. R times what gets us an r squared? R times r gets us an r squared. And it's true that 8pr times 1pr is 8p squared r squared. Now let's go for the next one. 8 times what gets us a minus 24? Well, that would be a minus 3, right? 8 times minus 3 is minus 24. 8 times minus 3 is minus 24. And then p times what gets us p? You don't need to put another p. It's already there. And the r times what gets us r squared? R cubed. R times r squared gets us r cubed. And last but not least, 8 times what gets us 16? That would be 8 times plus 2 gets us 16. Okay, and then the p times what gets us p? It's already there. The r is already there, so you don't have to worry about doing that last term. So there's your factored form, and the GCF happens to be 8pr. Let's move on to number 5. Number 5, you have 3 terms, a trinomial, and what's the greatest common value you could pull out from all 3 terms? All 3 terms, what's the greatest common value? Well, if you're looking at the coefficient 9, 18, and 24, you might be thinking, oh, 9, no, 9 doesn't work there, right? How about 2? No, it doesn't work. How about 3? 3 goes into 9, 3 goes into 18, 3 goes into 24. So let's pull out the coefficient 3. Then how about a's and x's? Well, we have one a here. There is no a's here, and there is no a's over here, so you can't pull out an a. Okay. How about x's? Well, we have x's. We have 3 x's here. We have 2 x's here. We have 1 x here. So we could take out at least, or the greatest amount of 1 x from all terms at the same time. Again, here's 3, here's 2, here's 1. So you could pull out 1x from all terms. 1x from all terms. So you're pulling out a 3x. Notice, again, you can't pull out a's. You can't even pull out b's because there's only a b in the middle. There's no b's out here. And you can't pull out even c's because there's a c here and no c's over here. So the greatest common value is the 3 from the 9, 18, and 24, and the x because there's x's in all 3 terms. And the maximum amount of x's you could pull out is only 1x. So 3x in this case is your GCF. What would be left over in the parentheses? 3x times what gets us a 9ax cubed? Well, 3 times 3 gets us 9, and we also need an a in there, and we need it to be an x cubed. Since we already have an x, we're going to need an x squared in here, right? 3x times 3 is 9, x times x squared is x to the third, the a is just up there. Okay, the middle term is going to be what? 3x times what gets us a positive 18? Well, that's going to be a plus 6 because 3 times 6 is 18. And notice that the middle term on the original has a b in it. And we also have an x squared. Now we already have an x out here, so this middle value in the parentheses is just going to be one more x, because x times x will give you the x squared that you have up there. For your final term, 3x times what gets you a 24cx? Well, 3 times 8, that's a positive 8. And we also need a c in there. And we also need an x, but we already have an x in here. So that's all you need, really. 3x times 8c, that would be 3 times 8 is 24. X times c is xc, or cx, in alphabetical order. And that's it. Now let's move on to the next one, number 6. Number 6 is a little different than the rest because when you try to factor out the GCF, 6, 8, 15, 20, wait a minute, 6 and 8 and 15, I could divide, well, there is no multiple in common in all the coefficients. So you can't pull out a GCF from all the terms. So you're stuck. I mean, there's not even x's in all the terms. You have an x here, an x there, and no x's over here. So you can't even pull out x's. You can't. There's a y here and a y there, but you can't pull out y's because there's no y's in all terms. So you're kind of stuck. You can't factor out the GCF, the greatest common factor. You can't do it because there's nothing in common in all 4 terms. So what we need to do now is go back to what we learned yesterday, which was factoring by grouping. So to factor by grouping, step 1, I have them right here, the 3 steps. Step 1 is to make 2 groups. Okay, so all I'm going to do is take the first 2 terms and the second 2 terms and put a little bit of space between them. Step 2 says factor out the GCF from each group. Okay, so you're just going to look at the first group and ask yourself, what's the GCF? What's in common with 6 and 8? Okay, you know it's 2. How about x is here and x is there? So you could pull out the GCF of 2x. So let me actually make a little more space here. Now let me pull out the 2x. And if I did pull out a 2x, what would be left in there? That would be a 3y. Okay? Now if I did pull out a 2x from the 8x, from the negative 8x, in other words, 2x times what gets us back to a negative 8x? That would be minus 4. Right? 2x times negative 4, 2x times negative 4 would actually take us back to the negative 8x. Now let's do the same. Let's factor out the GCF from the second group. In the second group, you have 15y, you have 20. What could you pull out? Well, you could pull out a 5. Okay, now there is no x's to pull out, but you could pull out the multiple of 5. So I want to pull out a positive 5. And if I pull out a positive 5, what would be left? I'm going to have 3y minus 4. 3y minus 4. Okay, so now third step is to factor out what's in common. And I put in parentheses binomial because normally it's the binomial that's in common right here and here in your first and second group. Okay, so you want to pull out what's in common, that binomial that's in both groups. Make some space here. So what I'm going to do is I am going to pull out that binomial, which is 3y minus 4. And if I do pull out that binomial, what would be left on the inside? Well, if both of these get taken out, then the 2x is going to be the only thing left over, 2x. And then if you, again, were to take out the 3y minus 4, the only thing that would be left over in there would be a plus 5. So I do exaggerated parentheses so you guys could visually see that the binomial is missing, right? You took the binomial, you took it out, it's missing now. The only other thing to do is to write it in the correct size parentheses, so it'd be 3y minus 4, parenthesis 2x plus 5. Okay, I hope this helps. We are going to pick up with number 7 on the next video.